Hi everyone! We are continuing the ROS2 Basics series with the third episode on creating a workspace and your first C++ and Python package. We'll use ROS2 command line interface, also called ROS2 CLI, to create the package and test them. I will soon release a dedicated tutorial to explore the functionality provided by ROS2 CLI, but in this video I will just present the command related to the workspace and package creation. First of all, what is a ROS2 workspace? A ROS2 workspace is the directory where you develop, build, and manage ROS2 packages. It typically contains the following subdirectories: src, where you will add your ROS2 packages; build, which contains the result of the build; install, where are saved all install targets after building; and the logs directory, which contains the log file generated during the build and runtime. The directories build, install, and logs are generated after the build of the workspace. Workspaces work with an overlay system. The command added in your bash RC in the previous video, source opt ros-jazzy setup.bash, allows you to use the packages of your ROS2 installation. In this case, your ROS2 installation is an underlay. When you create a workspace and add packages that contains Node, for example, those resources will be only available if you source your workspace with the source install command. Your workspace will be the overlay. Also, if one of the packages installed in your ROS2 installation and another version of the same package is installed in your workspace, the version of the overlay will override the version of the underlay. It's also possible to create sub-workspace within a workspace using the same overlay-underlay logic. The concept of overlay is important, but for now, you have only one thing to remember. In order to use the node of the packages you have compiled in your workspace, you need to source this workspace in your active terminal by using the command source install setup.bash. We will see the application of overlay when we will try our packages. To create our ROS2 workspace, run the following command in your terminal. This will create a directory named ROS2 Basic Workspace with a subfolder src, where we will create our packages. Now that we have created the structure of our workspace, we will continue with the creation of the packages. But before, what is a package? A ROS2 package is the fundamental unit of ROS2 code. Each package can contain nodes, message definition, launch files, dependencies, and libraries. To create a CPP package named CPP ROS2 Basics in our workspace, we will use the following command. This ROS2 CLI command creates the package with the necessaries file. It also creates in the package a basic executable node named example node CPP. Let's open the C++ package in VS Code to check what is inside. Firstly, you can see that we have our example node in the src folder. Then, we have the semakes.txt. This file is the build configuration for the C++ package. It contains instructions about compiling the source code, linking the dependencies, and creating executables. At the top of the file, you have the project name. After, you have the find package that finds the libraries required to build the package. Here, the only required library is rclcpp, which is the ROS2 C++ library. Then, you have add executable. This line indicates that our example node inside the src directory will be compiled as an executable. The target include directories command is used to specify the directories where the compiler should look for header files when building the project. For the moment, we don't need it, but it's there by default. The amend target dependencies, which allow to link the executable to libraries, like rclcpp for example. And then to finish, you have the install command that install all the executable in the proper destination after the build. The other important file is the package XML. This file contains metadata about the package, for example name, version, description, and specified dependencies. For C++ package, it declared with the tag depend the package required for the build. Once again, we have only rclcpp. Now that we have created and looked inside our C++ package, we will do the same with the Python package. To create a Python package named Python ROS2 Basics, with a node named example node.py inside, you can use the following command. Let's open the Python package in VS Code to check what is inside. By default, in Python package, the nodes are stored in a directory with the same name as the package. Then we have the setup.py file. This file defines the installation process for ROS2 packages. It specifies the package's dependencies and includes the folder to the node executable. The node executable are typically defined in the entry point section. Here we have our example node.py definition. The setup.crg file is optional but can be used to provide additional configuration for the setup.py. And we have also the package XML, which contains the metadata of the package as for the C++ package. Now that our packages are ready, we'll finish the setup of our workspace to be able to build. Before launching a build, you should check for the dependencies if you have cloned new packages. You can do that with the command ROS2 install. It will use the ROS2 tool to check for the dependencies of your package. If it's the first time you are building your workspace, you will also have to init your ROS2 with this command. Now that the packages are ready and we have checked for the dependencies, we can build a workspace using the call-can-build command. We return at the root of the workspace and start the build. This will combine both the C++ and Python packages in your workspace. Once the build process is complete, you must source the workspace to ensure ROS2 can find your packages. And you will need to do this command at the root of your workspace in every new terminal to use your package content. And now that the packages are built and the workspace is sourced, we can try to run the node from our packages. To run a node, you need to use the command ROS2 run with the package name and the executable name. So to test the C++ node, we do ROS2 run cpp ROS2 Basics example node cpp. You can see the print, so the node is working. Let's test the Python node in a new terminal. As I said before, you need to run the source command every time you open a new terminal to make your packages available in the ROS2 environment. Just to show you the importance of the source, let's try to run the Python node without sourcing. If you use the tab key of your keyboard twice, you will use the auto-completion of your terminal. You can see that the package is not found. After we source, the auto-completion is working and we can start our node by running the command ROS2 run Python ROS2 Basics example node py. The print is there, so the Python node is working too. Congratulations! You have successfully created a ROS2 workspace and your first C++ and Python packages. In the next episode of ROS2 Basics, we will discover the topics and develop our first publisher and subscriber node in Python. Be sure to like, subscribe and turn on the bell to stay informed about ROS2 Basics series and upcoming video. If you have any question or topic to suggest, leave a comment. See you next time!